But how do you make X-rays, you may well ask? Well, you start with an electron gun. In an electron gun, you have a heated cathode, and that's just a piece of wire. So this piece of wire here is a cathode. That means it's negatively charged and it's being heated. This causes electrons to escape from the wire, and this is called thermionic emission. The electrons then accelerate towards this thing here because this is an anode, so they accelerate towards the anode. If the potential difference across this gap is V, then the electrons, when they reach here, will have a kinetic energy of EV, E being the charge of an electron. All of this needs to be enclosed in a vacuum tube because air atoms, molecules, are massive compared to our little electrons. So if you've got any air in there, our electrons are going to hit it and not make it from here to there. So you need a vacuum inside the tube. All right, this is the electron gun part. So this is how we get electrons emitted and then we speed them up so that they then come out here as an electron beam. And remember, the energy of the electron beam is given by this formula. All right, then you are going to fire your electrons at a tungsten anode. So again, it's something that's positive. It's going to attract the electrons. And this tungsten anode is going to be rotating. When the electrons hit, electrons in the atoms in the tungsten, those tungsten electrons jump up into higher energy levels, and then when they fall back down again, they're going to emit our X-rays. So that's how you make X-rays. Two important points here about the tungsten anode. Number one, why is it made of tungsten? Number two, why is it rotating? The answer is the same for both. It's because these electrons hitting the target, most of the time, more than 90% of the time, they do not cause X-rays to be emitted. Instead, all this energy just goes into the thermal store of the anode. And so this anode is going to get really, really hot. That's why we make it out of tungsten, because it has a very high melting point. If you used a different metal here, you'd melt the target every time. And it's also why you rotate it so that the electron's beam is not hitting the same part of the target every time. So parts have a chance to cool down before they come round and get hit again. Okay, so to summarise that again, you have a heated cathode. Electrons are emitted by thermionic emission. They are accelerated towards the anode. The kinetic energy that they have when they leave the electron gun is equal to E times V, the potential difference. We now have an electron beam. This is fired at a tungsten anode, which is rotating. It's going to get very hot, and that's why we have the tungsten and the rotating. The electrons, when they hit the tungsten, their kinetic energy is ultimately turned into X-rays. Now, I'm just going to say quickly here that if you are doing the AQA medical option paper, you need a bit more detail. And here is the very memorable graph. So, in fact, there are two ways that X-rays are created in the tungsten anode. The one that I've mentioned there is the method where electrons jump up to higher energy levels because they've been hit by electrons from the electron gun, and then when they fall back down they emit X-rays, and that's how they lose the energy. So in that case you have atoms that are being excited and then de-exciting, and that's why the X-rays are created. Now they are only created at particular wavelengths because these correspond to the energy gaps in the tungsten atoms. As well, though, you have this continuous spectrum. And so this is X-rays with all these different wavelengths. And they are being created because the electrons from the electron beam, when they pass through the tungsten, they are slowed down. And when they slow down, they obviously lose kinetic energy. And this is where more X-rays are being created. And so this can be called braking radiation. You might have heard this term. The X-rays that are created this way. Or the German for this is how I was taught it at school, Bremsstrahlung radiation. You might have heard that as well. Okay, here though is an OCR question. So a teeny tiny 2 marks. Describe briefly how X-rays are produced in an X-ray tube. And you get 1 mark for saying that electrons hit the tungsten or the metal or the anode, and a 2nd mark for saying that their kinetic energy is transferred into X-rays or photons or EM waves.